Walk into an old stone house, a castle, a monastery, or a desert home, and one detail often feels strangely oversized: the walls. The windows do not sit flat on the surface. They sink deep inside, almost like small tunnels cut through stone. In some historic homes, those walls can be half a meter thick or more. To modernize, that can look wasteful. Why give up so much space? Why use so much material just to hold up a house? It is easy to assume old builders made thick walls because they had no better options. But that assumption misses the point. Those walls were not just walls. They were temperature systems, structural support, sound barriers, fire protection, humidity regulators, and social statements. To understand why, we have to begin with something modern homes usually hide inside machines: temperature. Let's get into it right here on Secrets of Simple Things. Before air conditioning, the wall did the work. Old houses were built before electric fans, air conditioners, modern insulation, and mechanical ventilation. If a room became too hot, cold, or damp, there was no switch to solve it. Comfort had to come from the building itself. Builders had to think with materials, sunlight, shade, wind, windows, and wall thickness. They were not always using modern formulas, but they were using generations of trial, error, and local experience. In many places, comfort was survival. A house had to respond to its climate, and thick walls helped create delay. Heat did not pass through instantly. It slowed down and arrived later, making indoor temperatures more stable. In hot climates, that delay could turn an unbearable room into one that stayed surprisingly cool. The secret of thermal mass. The reason thick walls worked in hot places comes down to a simple idea. Some materials do not react to heat quickly. Stone, brick, adobe, and earth can absorb heat slowly, hold it for hours, and release it later. Architects call this thermal mass. Think of a thick wall as a sponge for heat. During the day, sunlight and hot air press against the outside surface. Instead of letting that heat rush straight into the room, the wall absorbs part of it. Because the wall is thick, heat must travel through a long, dense path before reaching the inside. By the time it arrives, the sun may be lower, the air cooler, and the worst part of the day may already be over. This is why thick adobe and stone homes became useful in the Middle East, North Africa, and Southern Europe. Some centuries-old rooms can still feel cool without machines. The goal was not to block heat forever. It was to slow it down, so the house became less reactive to sudden outdoor changes. This works best where the climate helps, especially when days are hot and nights are cooler. It is not magic everywhere, but in colder places, the same thick wall could serve almost the opposite purpose. A heat battery for cold nights. In colder climates, thick masonry was valuable for a different reason. Instead of delaying outdoor heat from coming in, it helped keep indoor warmth from disappearing too quickly. Before central heating, warmth came from fire. A hearth, stove, or fireplace was survival. Wood had to be cut and carried. Coal or peat had to be bought, stored, and kept dry. Letting heat escape meant wasting labor, money, and resources, so the building had to help. Imagine a family after sunset. The fire is no longer roaring. The room is darker. Outside, the air is cold, but the stone and brick around them still hold warmth. Slowly, that stored energy returns to the room. The house is not warm because of a thermostat. It is warm because the building has been storing energy. This does not mean thick walls worked like modern insulation. Some masonry can conduct heat. Their value often came from mass and delay, not perfect blocking. Yet comfort was only one reason. In many old buildings, the wall was not just protecting the room, it was holding the entire building up. When the wall was the skeleton. Today, many buildings do not need their walls to do all the heavy lifting. Steel frames, reinforced concrete, and engineered columns often carry the real weight, while walls divide rooms, seal the interior, or hold insulation. Older buildings were different. In much of traditional construction, the wall was the skeleton. It carried the roof, the upper floors, and sometimes towers, arches, or stone vaults. The lower the wall stood, the more pressure it had to survive. That is why medieval castles often rise from massive stone bases. It is why old churches can feel heavy and enclosed. It is also why some townhouses feel most solid at street level. By modern standards, many of these buildings were overbuilt. But that was not foolishness. Failure was dangerous, and without modern frames, material had to compensate. Thick walls resisted compression, weather, storms, earthquakes, and centuries of use. And because the wall was already thick, it gave people another advantage in a more dangerous world. A house that could defend itself. In earlier centuries, home security meant more than turning a key in a lock. A house could stand amid raids, bandits, unrest, violence, and war. So the building itself had to offer protection. Thick stone or brick walls were difficult to break through. Narrow windows reduced weak points. Deep openings made it harder for outsiders to reach inside. Solid construction turned a home from shelter into something more defensible. This was clearest in castles, fortified houses, and walled estates. But ordinary homes could benefit too. A thicker wall bought time, and in a dangerous moment, time could mean survival. The same logic applied to fire. Urban fires were a constant nightmare in timber-built cities. The Great Fire of London in 1666 showed how quickly flames could move through a wooden city. Brick and stone did not make a building fireproof. Wood inside could still burn, but thick masonry could slow flames and help parts of a building survive. After major fires, many regions pushed more strongly toward brick and stone. In a world without modern emergency systems, the building itself had to buy time. But some of the most useful effects of thick walls were quieter, daily ones. Quiet rooms and breathing walls. Old towns were rarely quiet. Streets carried the noise of animals, carts, markets, workshops, neighbors, and people in narrow lanes. Before double-glazed windows or acoustic insulation, dense materials like stone and brick helped soften that noise. A thick wall absorbs and blocks sound waves, making the home feel more private, calmer, and protected. The same heavy wall that resisted weather or force could turn the outside world into a distant murmur. Thick walls also helped with moisture. When people say old walls breathe, they do not mean air flows through them like lungs. They mean moisture can move through certain materials instead of being trapped completely. Stone, lime plaster, earth, breathable renders, and some traditional bricks could absorb and release moisture slowly. Combined with wall thickness, this helped regulate humidity. Modern buildings handle this with vapor barriers, membranes, insulation, and mechanical ventilation. But old walls were not immune to damp. Poor ventilation or the wrong modern repairs could damage them. Their strength came from the right materials working together. So thick walls made houses more comfortable and safer. But they also said something about the people who owned them. Thickness as a sign of power. A thick-walled home was not only practical, it was also a public message. Building in stone or brick required labor, skill, material, transport, and time. Not everyone could afford that. So when a family owned a house with heavy walls, the building spoke before anyone inside said a word. It suggested resources. It suggested permanence. It told the community that this household was established, protected, and here to stay. In some cultures, heaviness itself carried meaning. A solid house could suggest dignity, inheritance, authority, and long-term stability. The wall was both engineering and language. It protected the family physically, but also announced their place in the world. A house was never just shelter, it was identity, memory, and status built into stone. And that is why old walls still matter today, not only as architecture, but as records of how people lived. A historical record written in stone. Old walls also work as records. To historians, thickness is not just a measurement, it is a clue. The kind of stone, the size of the bricks, the lime in the mortar, the plaster, and the way each layer is arranged can reveal what a community had, what it valued, and how it solved problems. A wall built from local stone tells one story, a wall made with imported brick tells another. These details can point to trade routes, available technology, climate needs, and cultural priorities. Even repairs matter. A patched section, a blocked window, or a different layer of brick can show how a house changed over centuries. Each wall is like a document, except its sentences are written in weight, dust, lime, and stone. And after centuries of replacing thick walls with lighter, faster construction, modern architecture is starting to look back. The old idea hidden in the future. That return is not about nostalgia, it is about energy. As energy use and sustainability become harder to ignore, passive design is becoming valuable again. Thermal mass, shade, airflow, and natural cooling are not relics. They remind us that a building can work with its climate instead of fighting it every hour. That does not mean modern buildings should copy old houses. Today's construction can be lighter, safer, faster, and more adaptable. It can combine old principles with better insulation, ventilation, engineering, and materials. The lesson is not that old houses were always better. The lesson is that old builders often understood their climate deeply, so the next time you see an unusually thick wall, it may no longer look like wasted space. It was climate control, heat storage, structural support, a security barrier, fire protection, soundproofing, humidity regulation, a status symbol, and a historical record, all at once. What looks crude may actually be centuries of practical intelligence built into one simple object. If you enjoyed this journey into the hidden intelligence of old buildings, leave a like, subscribe to Secrets of Simple Things, and tell us what simple thing we should explore next. Because sometimes, the most ordinary details are carrying the deepest stories.